Hey everybody. It's nice to see you all. Friendly crowd. I always love it. Um, I'm Etienne. I work at Shopify as a staff developer, big titles and stuff. It just means I get to spend a lot of time on thinking about architecture and things. One of my favorite subjects is dependency injection. And I can tell you without a doubt, it's actually a very controversial subject. And why is that? It's because it's actually kind of hard to get it right. Now, today we're going to talk about dependency injection with Toothpick 3. Like, we use Toothpick 2 on our app at Shopify. I quite like it because it's a lightweight solution. And they came out with Toothpick 3, which has better support for Kotlin and all sorts of nice things. And we're going to look into that today. But first, clicker fail. OK. We're going to talk about the basics. So who here uses dependency injection on a day-to-day basis? Please let it not be almost everybody in the room. OK. Well, we're still going to go through the basics. For the folks among you, there's still a few hands that did not get raised. And if you are experienced with this stuff, I will tell you the following. It's good to be able to explain the basics to other people who are not so great at this stuff. Then they can understand and be enlightened. So take this, crib notes, steal my deck, whatever. There's a GitHub project with it. I'll link to it later. All right, so what's a dependency? Basic, right? References to other classes to complete some work. And all apps have these dependencies. So let's imagine that we have a class called truck. It would depend on something called an engine, right? Fair enough. So, what else? Engine is a dependency of truck. Cool. What's next? Dependencies, when you're using dependency injection, are provided to a class. So instead of just having truck create its own engine, you just make sure that the engine will be provided to truck at creation time. All right. So if we look at code, oh, you evil, what? Wait, let me just double check what's going on here. Oh my God. The code was definitely there.
Everybody open his laptop?
Do you have two slides, one with the code empty?
I am
and the other?
very disappointed with Keynote right now. Wow. Yeah, no, Keynote, seriously. You have no idea how much I messed around to get the color right on all of these words that are not there. All right, so what do we do? You know what I did too? I typed all that sample code in a nice little class that I deleted earlier because I was like, I don't need this anymore. This is junk. Right, anyway. Yeah, kind of. It's not that hard, really, isn't it? So I'm going to type like really janky code. So without DI, you have a class truck. Let's go for it. Oh, jeez. Yeah, of course not. Wait, I know. Sorry. Give me a sec. I'll fix this. And thank you for the warning. You ever see those talks where nobody tells the presenter that they're not actually showing, and they go on for 5 minutes before somebody goes, sorry, but... All right, cool. So without DI and without code. OK, so let's say we have a class truck. Oh, come on. All right, thank you. Wait, this is nice. Is this typical of your... Are we good? We'll leave it for a sec. I'm going to start typing. I wonder if that's what's like... Anyway, so you have a class truck, right? And it needs an engine. And now my syntax is going to be terrible, obviously. So we need an engine. And if you don't have DI, what you need to do for this engine is to build it yourself, right? Cool. Not a big problem. The thing is that if you do this, right, truck is responsible for engine. That's fine if there's nothing you need to pass in, but what if you need to configure it, right? You start thinking about it and you add more and more of these, it might be a bit too much work for the class to take on to build its own stuff, right? So with DI, and I'll copy paste right here because I don't want to type that again. All right, so with DI, I'm crying inside right now. So cool. All right, it's cool, it's cool. We roll with it, right? Show us go on. So with DI, what do? Well, it's actually super duper simple. All we're really saying is that we're going to give you this engine truck. You're going to be a happy little truck. And what do we do to give you something? We just pass it in the constructor. Yay. Magic, right? So now you missed a little animation where the little box went out and the arrow came down, and I spent like a fair amount of time this afternoon to try. Oh, there you go. Yay. That's cool. All right, so I hope none of the other code went away. All right, so big takeaway from this. You should always apply DI principle in your app. All right, so that's my big takeaway for DI right now. And we're going to find out why right now. So on the importance of DI and speaker notes, let me just get back to my separate display setup here. Because I'm like that. I roll off of speaker notes. Are they all gone? I fucking hate you, Keynote. Are they really all gone? Let me just check ahead. Spoilers ahead. No, I'm good. It's okay. Most of the other things are here. We'll be good. We'll have fun. All right. So, okay, we're good. No, I know. I'm just double checking my presentation before I go on. So if you, the thing is that if you look at the latest guidance for the architecture component, from the architecture component folks at Google, this is what you're going to get, right? They really tell you, hey, folks, always apply DI principle in your app. They're not saying you must use Dagger or you must do this or that, but they are saying that these principles, like passing dependencies and constructors, are, it's an important thing. Right, now we're going to find out why. So the first thing is it allows you to reuse your code in a really nice little way. So concretely what that means is that, for example, here, if we have code for truck, right, there's like a lot of things going on. You can swap the engines out, and truck itself doesn't need to change. You just gave it a new engine, truck still behaves as it did. You can afford to not rewrite truck, because if it was aware of the engine and the type of engine it's running and had to configure it, you'd need to write the Cybertruck class, right? Instead of just reusing truck and swapping in the engines. Reusability, fairly straightforward. So the second reason why DI is important is the good balance of loosely coupled dependencies. So when I heard this first, I was struggling a little bit with like the fuzzy language. So what does that exactly mean? Well, if you think about service locators, so if you're aware what a service locator is, it gives you a lot of the same benefits that DI would, except the service locator, you ask it actively for a dependency. So you would say to the service locator, hey, find me an engine. And you would do this from the truck class. But with DI, your dependency become the API surface of your class. So by simply switching this from I'm asking for a thing and I'm being given the thing in the constructor, well, you can already say that DI is a bit better balanced than a service locator would be. So that simple little fact makes your code a lot easier to refactor. So we're going to look at a really simple example. We have the Cybertrucks, let's say. Like we decided, okay, we're going to write that. That's like pre-refactoring. So we have a lot of source code, right? Those things don't drive themselves. You have to write the code to explain to it how to drive itself, blah, blah, blah. So what we can do is put that in a different class and start putting the complex logic code in different classes. We take little bits of what we're doing, we shard it off in different classes, and we start passing it in the constructor. That makes sense because you can split it in further, smaller bits. So you can take the massive Cybertruck class and turn it into this nice little diagram right there. So lots of fairly obvious for us to have a bit more experience, but not so obvious for people new to a platform. This makes it really easy to have multiple people working on separate parts, right? If somebody's working on the air filter class, they don't have to call me every second saying, hey, I just changed something to Cybertruck. I'm afraid it's going to break everything because I have access to all that state. And then you can also avoid people writing air filter code that starts looking at the temperature of the radiator for some reason, right? So you isolate all the little bits, and by splitting this up in logical module with a clear API surface, you make it a lot less likely that one change will impact all of the system. All right, cool. DI also helps with testing. So I'm going to fly through that one kind of easily. If you need to test your truck, you pass in a fake engine, and you're going to test your truck, and everything's fine. If you want a test that fails, you pass in a fake failing engine, and then you're good. All right, cool. So hopefully I've convinced you right now that the very basic principles of DI are awesome. That's hopefully, anybody not convinced? Raise your hand. I'll try to convince you by the end of the year. When people are not super confrontational here, that's nice. All right, so This is a super scientific graph. It's actually totally, absolutely based on pure opinions and subjective information. There's no actual numbers behind this thing, right? Like you see those graphs a lot. You can just change whatever you want. Like typically I would put React Native here, cost of product, sorry. I'm on a rant against React Native later. And native development, maybe, I'm not sure. Anyway, so right now I'm just like stalling because I have to admit something. I've been cheating on my deck so far. My presentation is a total clone of the following talk from this year's Android Dev Summit. So I actually recommend you go watch this talk, but they're kind of lying about the dependency injection part, except for the part I just showed you. Like, the rest of this talk is all about Dagger, right? And it's all about recommending and saying to people, use Dagger, damn it. And I am actually kind of behind that, to be absolutely honest. But some of you might be thinking, right? And I can tell you something, there's a lot of people that think like that. And I think it's a fair comment. Like if you've ever set up Dagger, or if anybody is familiar with the U2020 project by Jake Barton? Yes, a few nods. So if you just look how they set up the drawer, the different build flavors. And so the thing with Dagger is it kind of integrates with your build system a lot. And that's cool, except if you have a project with maybe, I don't know, 30 modules and 50 people working on it, and then 80% of those people hate DI, don't want to use it, cry about it, a bit like that guy. And you know, I understand where that comes from, right? Like the first thing is they don't even understand why DI is kind of nice. And then the second thing is Dagger is complicated. But no worries, everybody. Dagger is going to get simpler, and that was the big news at ADS. We already had improved documentation and awesome code labs that were released right on the day of the summit. And we're going to have some super exciting stuff like better Kotlin integration, simplified bindings, automatic injection, better view model handling. There's even like constructor injection coming, which we were talking about a few seconds ago. So this is really cool stuff, except for a small problem, right? What if I want simple DI right now? What if I wanted it a year ago? So you kind of already know the answer, right? I spoiled it with the title. With Dagger, yay. We're now, the future, awesome. So you all get that stuff, at least a fair amount of it. You're going to get better Kotlin integration with Toothpick 3, simplified bindings, automatic injection for the most part, and better view model handling right now. All right, so this is the part where the talk is going to go a little bit in the weeds because preparing a ton of slides that highlight very specific bits of code sample is a very long process. But bear with me, I think we have a bit of time ahead of us, and I'm going to try to keep it nice and simple for like 15 minutes. And I'm going to open the floor to people to just like start drilling me on stuff while we're mucking around in the IDE. Right, but first, we're going to set ourselves up with an imaginary app. How do we use DI with an actual app? So we're going to imagine a small component in a record store management app. I'm a big vinyl head. I would like to learn how to scratch records properly, and I have like a whole kit for it, and I like that stuff. People that know me know this about me. So I just decided record store app, that's kind of cool. Right, for this app, this screen is basically showing a record front end, so it's like an LP, a little photo, title, description, right, that's cool. You basically edit this thing, so you have pricing, amount in stock, a SKU, and you have an interface to edit these things, so you can, you know, increase and decrease the price, the amount in inventory. This makes absolutely no goddamn sense for the SKU. Like, you have to enter a SKU by hand. A SKU is just like a code. Ignore that. And then an update button, because, yeah, why not? So, again, this is just a thought exercise that we're not putting this live today or anything. So, forgive me. The second screen, we're going to just forget about it right now, because that's the future tomorrow. OK, so if we focus on the first screen, I went nuts with fragments with my sample, just because that's what you kind of want to see in the DI engine. You want to see how it behaves with the wonderful Android lifecycle and all of its little hanging out bits and things. So we have like no less than, what, 7 fragments, 6 fragments in there? Yeah, in that one activity. That's cool. We'll see. That's nice. Like, it's another point to say that DI makes this kind of stuff kind of easy too, which is kind of interesting. Cool. So nice, like that animation. Like I worked on that a little bit. All right, cool. So this app is going to use MVVM-ish. So as a basic thing, when we go through, like I wanted to show everybody this so that you can understand a little bit while we're surfing around code, you get like the big structure. So we're going to spend like just like a few seconds on this. So this idea of having a centralized record model. So this is going to be, for those of you that are in the know, a singleton at the application level. This is going to be sort of our master, reference. So this basically never goes away. It's just sticks around the life cycle of our whole app. Then we're going to go straight into view models. View models are very popular. If you ask me, I cannot understand why, but I put them in there because, it's cool. We'll play around with view models. They're part of why DI is challenging and what problems that Toothpick and Dagger will solve soon. So I might stop being so down on view models after that. So if you're not aware what a view model is, it just sticks around regardless if you rotate your screen and everything. As long as you're on the same screen and those fragments are effectively the same, this will stay alive and keep your state through the whole duration of the time that that fragment is on screen, regardless if you change configuration 20 or 30 times, right? Then we're going to have the fragments basically consuming this view model or pushing stuff to it. So what I mean by that is that if you have a fragment like those control pricing and inventory, that's just a fancy name I gave them for buttons that you press to do stuff. And these are going to send events to view models and saying, okay, I need to increment the quantity or increment the SKU, which makes absolutely no sense. And then you also have things like showing what the model looks like. So we have 2 fragments, the record header, where if you remember the little picture up the top there, that's where that was. And the idea of the record price inventory SKU fragment is this thing right there. So all of these have their own view models. They're all hanging off of one activity in this case. And just for the sake of the example, I had added an activity view model, although I have no idea what would go in there at this point. But typically that might also want to connect to this. But that's just in there to show off DI more than for any actual purpose. And it's all part of one application. So with me so far, cool. So we're going to focus mostly first on the record model. And this is the part where we jump into the IDE and everything goes to hell. All right, so first off, I'm reading my notes here because I wanted to be a little bit structured because I'm a bit of a scatterbrain, so if we start looking in the code, I jump left and right, somebody has to stop me. But first, what I want to do is to look into constructor injection and in the record model. That's the most high-level thinking that you get in DI, especially on Android, where it's nothing specific about Android. So I'm going to jump to that right now. This is the part where I want to actually show you content. There we go. Cool. And I'm sure this is absolutely readable, right? So, pro tip, if you want to present stuff, you can always create this. Wait, okay. ViewSonic hates me again. We'll just give it time to settle. Is this readable? People in the back, kind of okay. I can make this bigger. Yeah, cool. All right, everybody's got much better eyesight than me. Awesome. So, not this class. What we want to look into is the record model, as I mentioned. See, those notes are already paying off. All right, cool. So, we're looking at constructor injection. Now, to be said, I showed you earlier how most of the very high level use DI this way all show you constructor injection. And that's typically because it's a nice way to put that API surface I talked about very briefly. Like if you have one constructor that takes all these arguments, you've just effectively very clearly indicated to everybody else in the system, okay, I need these 2 things to operate. So for tests, that's really practical and all sorts of things. There's another thing called field injection, which happens after the object is constructed, and we'll talk about that in a minute. It's the takeaway if you're new to DIs, that's not as great. There's basically because you lose a little bit of that API surface goodness that I've been talking about. All right, so this is new in Toothpick. If you've played, who's actually played around with Toothpick 1, 2, or 3? All right, very few people, that's good. So if you're from Dagger, you're probably going to recognize a lot of this stuff. I think it's pretty classic, but typically this would have, like in the past with Toothpick, you would have written something like as follows. You would have had an @inject annotation, and you'd have to mess around a little bit. Toothpick 2 and 1 are originally more into built off of JVM and Java. So that led to a few like unpretty things like this, where you'd have to explicitly say constructor and use the @inject annotation. If you're wondering, this is like the one straight from the JSR 331, 330, 301. I always forget. Anyway, like this is like an official old school injection annotation that's been here since 2005 or something. All right, so to avoid all of this, what Toothpick 3 adds now is that you have this nice inject constructor annotation, which takes care of, like, just simplifies the injection site. Now, there's another annotation right here called @singleton. So that tells Toothpick, which is configured on this project, these two things. First, it says to Toothpick, okay, this is a class that you will need to inject. Like, pay attention to this. You'll need to find shared prefs and resources. That's effectively what it's saying. The other annotation is a bit more fancy. So if you remember the graph I just showed, we have application activities, fragments, all that lifecycle and scoping goodness. So @singleton here is effectively telling DI, telling Toothpick, hey, Toothpick, I want only one copy of this to live in the graph, the dependency graph, ever. So this will make sure that we only have one copy of record model in our app, which is what we want in this case. Cool. So that's constructor site injection. I've basically added nothing to this class except a logging message here that we'll sort of look at a bit later when we start playing around with how does this play nicely with rotating the screen, config changes, and all that. We'll take a look at how that happens. So since we're now at the part where I didn't have time to write 150 slides and animate all of this stuff, we're going to simply run in debug mode and hit this breakpoint and just take a look for ourselves, and hopefully that will work, that these two things will be provided to us by Toothpick. And then I'll move on to the next point. So we'll give the builder a few seconds. Shouldn't be too bad. All right, it's started, and we're stopped here. Okay, cool. I'm going to do something now because it's nice that the code itself is readable. Wait, what I want to do is this. I just want to make the font bigger. To do this, oh, right. I'm not sure that's going to work. I'll try this. Maybe ViewSonic will explode, but apologize in advance for to need to go to their equipment. That's it. I killed the screen. Oh, it doesn't like. Oh. All right. No jokes. Oh, there it is. So, I hope your speakers are okay. That was funny. I totally did not expect to break something for real. All right, cool. So, I can reduce the font size a little bit here just to make it a little bit more friendly. Yeah, that's still very readable. And we can sort of see what the debugger is doing as well. So what I wanted to point out is that if you see here, so hopefully people are familiar with the debugger, but I'm actually going to ask, like, is this like something you do on a daily basis? I know some of you are more like old school Android folks that, okay. So this is the call stack, right? And this is where we are in the program. We're stopped at the blue line, and then we have, in theory, access to shared prefs and resources. Now, what I want people to note very quickly is that I didn't put a val in front of these or a var. So in Kotlin, what that means is that these things are only going to be available while I'm in the init block, or if I'm trying to use them to initialize vals or vars, fields basically that have been added to this class. So this is actually a nice little trick if you want to avoid, not exactly leaking, but if you're using shared, so what's happening here is shared prefs and resources, right? They're from the system. And Toothpick, I'll show this later, has this nice default binding set that gives you all the stuff that you would want from the system for free. I'm pretty sure Dagger has the same thing. But you don't necessarily want to keep around a reference to resources. Maybe all you want to do when you initialize that model is to grab, I don't know, an image from the resource back. Or you want to write something in a shared preference. This is say, I started today or something. Or you want to find out some piece of information in the configuration. So you don't actually want to keep the reference to these two things, but you want to be able to access them during initialization and just like leave them be. So this is a nice little trick that you can use. Simply not put val in front of it, and they're going to be temporary and they're going to go away right after. Cool. So, and then we can see, as I was saying, that shared prefs and resources have indeed been ejected by Toothpick. Yay, good work. All right, so we're just going to let that run, and I'm just going to check my notes again. What were we talking about next? Right. So I've been mentioning that this is constructor site injection, and I also said that there's something called field injection. So why if everybody prefers constructor injection, why would we need to ever do field injection at all, right? What's the point with that? So let's just jump into foo fragment. I'm going to explain a little bit. So what is, first of all, field injection? This is these two things right here that you can see. So again, shared prefs, and this time account manager. Another piece of, another dependency provided by the Android system. So here we're in a fragment, and for now, the majority of the devices out there and the Android SDK don't really support injection at the constructor site for fragments. So fragments activities and view models are built by the Android framework for you on your behalf. And so that means that you can't just let a DI engine like Toothpick or Dagger right now, for the most part, inject them on your behalf. You have to ask the system, and the system has to take care of it for you, and then maybe you can do stuff. So right now with Fragment, what we're doing to still keep our DI goodness is what we're using the second best type of DI, which is field DI injection. So what we do is that we take fields like this one. So in this case, we have a var, late init var shared prefs, and we want to get it from Toothpick. So we add the @inject annotation in front of that field, and Toothpick during build time will do its magic to basically make sure that it can look up in its map of dependencies and provide that for you after the fragment was built. And there's a little bit of magic there involved, but we're going to get into how that works in a minute. Like, we have to somehow do a pass on the fragment. We have to inject the fragment at some point. I'll show you later how I've been doing it in this sample. But all we need to think about is that the system will construct the instance, and then we will do the injection for these fields by calling Toothpick and telling it, take this instance of the constructed object from the system and inject that. And then as long as we do this like early in the initialization phase, like as far as like the developers are concerned that are using this stuff, it's just as if they would have called a constructor, right? It's just a bit less pretty for the whole API surface thing. So that was the first way of injecting a field. The second big way of injecting a field with Toothpick 3 is by using the inject KTX method they've added. So they've built their own Toothpick KTX. So for those of you who are wondering what the hell is a KTX, it's like what we've used to say basically to call libraries that are extension functions on top of things that are already there. So they've added extension functions, Kotlin extension functions to their library through that KTX pack. And now we get something like inject. So what's kind of nice about the by inject instead of the @inject is that you see that if you're doing an @inject, you're sort of forced to go with a late init var. And what that means is that this thing is mutable. Somebody could come along later on and just change it, which is really not great. Like if you want to really benefit from Kotlin's immutability, you really want to use vals as much as you can. So if your DI system, as it used to be with Toothpick 2, forces you to use light init var, it's kind of a downside. So by adding this inject DSL to the system, you can use more idiomatic Kotlin code to effectively inject your fields. So here we see we have a val account manager, that's immutable, that's nice, life is good. Again, the reason why constructors are a bit superior to this kind of stuff is that you can't pull the same trick I just explained, where it's, you could just take the account manager, use it during the init, get stuff from it, and then only keep reference to the stuff you need. No, you're going to have to keep the account manager around. That's not such a huge problem. It's slightly less pretty. All right. Again, as you know, I have this init block here that just reports the commit to logcat what's going on. So that's because later on we're going to look a little bit at how the whole lifecycle interacts with the whole graph of dependencies that we have in this app. And we do nothing in this otherwise. All right, so enough of that. What else do I want? Explaining automatically. I think I've done that pretty well. All right, so let's see. Right, I'll go back to the deck for a sec. I don't need my notes for this. So the thing about these system field and like these system created classes that you're going to end up injecting, if you take the code that you would need to inject, say a fragment or an activity or a view model, and put that in every single activity, view model, and fragment that you have, you end up with like a pretty big amount of boilerplate, which is represented by that huge log at the beginning, right? So what we want is to have the strict minimum of boilerplate. We basically want everybody that uses Toothpick and DI in general to feel like it's magic. Like you just put annotations or use a by inject on your fragment, activity, whatever, or your constructor, right? You just put these little, very short little single-handed things, and everything gets injected and it's done. You don't necessarily want people to be aware too much of exactly how the sausage factory works, except when you do, which hopefully we'll have time to get to by the end, but yeah. Just on time, how are we doing? Like I think I'm like 20 minutes in. Am I completely out of it? It's about that? Okay. We might, well, I'll probably skip or go very quickly over bindings and answer questions after, not to bore everybody to death. All right, so what I have to also explain here is that scoping is kind of complicated on Android. So I'm supposed to have a slide here that shows like if everybody's seen like the diagram of life cycles for activities and fragments on Android, right? Like I have it permanently anchored on my desktop. The slide, imagine in your mind's eye, the slide that's supposed to be here is like, I saw the best Christmas gift ever, I think. We should all buy each other that for Christmas. It's a coffee cup with the life cycle graph on it. So you know what I want. That's my secret desire right now. That's on my wish list. Anyway, so imagine that graph. And then we're going to talk about scopes. But these are DI scopes. Okay. So what am I talking about? So if you think about life cycle, and you think about dependencies, right? Like when you inject certain dependencies, there's certain things that you can't keep around. So the simplest example I can think of is if you wanted to inject the activity context into a fragment, you don't need to do that because you get access, but just to like sort of basically understand the idea. If you have something that's in your system that's temporarily lived, that should die alongside the activity. Oops, I'm going to need my laser pointer here. So if you have one of those dependencies that should only live as long as an activity lives, that should be cleared up when the configuration change happens, and then brought back, recreated when it comes back. So it kind of means that if you're asking your DI system for such type of dependency, you need to be sure that your DI system handles that lifecycle correctly, right? And that's where most of the technical difficulty around using DI on Android comes from, in my opinion. So what I'm showing here is like a diagram of the scopes that I've put into this sample app. Like we might not go into the nitty-gritty of how everything works, mostly because the sample app is already available on GitHub. I just want to show everybody like the big lines and not bore everybody to death, which I'm probably dangerously close to at this point anyway. So we have the application, so that's the thing that stays alive, the whole life cycle of your application. If your application is killed, the process killed off, that goes away obviously, and everything underneath it, right? Now, with view models, things get a lot funkier than they used to be, because if you want to hang off of that, you need to think about what's the next longest lifecycle below me, and that is the activity view model lifecycle, as I call it. So what do I mean by this? So when an activity is on screen and it has a view model, that view model will, in the instance of that view model will stick around regardless of configuration change of the activity, right? So even if this activity here, basically the main activity is created, destroyed 15 different times, and you get 15 different instances of it, the view model only has that one copy that's going to stick around forever. So that's cool. So if what you want is somebody under that view model to get a dependency that's been defined here, right? You kind of want that thing to be at this, so basically you want your application to have underneath it another scope where those dependencies will live in there, apart from these, right? And then the next thing that you need to think of is that if my activity needs literally an activity view model or something in that lifecycle, it should get it from here, right? So all of the idea of these scopes, you have to think of it as a tree. As you go through the lifecycle, these things get collected in the right time. So application lives super long time. Activities live fairly long. Underneath of them, they have a ton of little activities that come up and down every time you rotate the screen. And if that activity has 15 fragments on screen, whatever, well, okay, you can't just like hook up the fragments underneath of here. You need to think of the fragments view model, because those things are a thing. There's view models that are hooked to the fragments that have their own life cycle, which is only as long as that spiritual, the thing that we're copying here, the class type here, is cloning, if you see what I mean. And then you have this guy here. That's where things get really funky. I'm only going to touch on this now. If you're really interested in how that works, you're going to have to go dig in the code for yourself, because that would be like another hour, well, at least another 10 minutes on its own. The idea is that if you're, so who's aware here of ViewPager? I'm expecting hands, and then also show that you're alive. Thank you. So ViewPagers, if you've played around with them, when you have fragments in them, right? If you have like, I have like details fragment. So if I have ViewPager, I'm going to have like 3 of those alive in the system at the same time and 1 on screen. Right, so that means that this little fragment right here, this scope, this view model, it's limited to a copy of that type of fragment that is in the ViewPager. So things are getting kind of complicated right here. So if you were scoping, we'll see in a second, involves a key, right? So what that means is that you need to basically say, I'm scoping on this unique thing that has a life cycle. Now, it's quite practical to say, I'm scoping on the class name, right? Because you're saying, okay, as long as this class has an instance, there's only one instance of this type of thing alive at any one given time, we're good. As soon as you get into a ViewPager, you end up in a situation where one single class can be alive 3 times. And so you can't scope on the name of that thing because that's not unique. You need unique key per thing. So you need a special strategy that I'm not going to go into, which is effectively just taking the class name and adding an ID to it. But you need to handle that. And that's something you need to do, at least for now. I'm going to be talking to the Toothpick repo handlers to see if we can add something to that, if it makes any sense. Anyway, and then fragments. All right, that was long. Did I mention I hate the lifecycle? It's super complicated, I feel. Like, that's where I lose everybody usually. Anyway, so we're going to get into real trouble now, because we're going to go back to live coding and look at how that whole mess works. It's also going to be a chance for me to show you how you actually would manually inject the code, and you'll get an idea of how much boilerplate you'd have to stick everywhere. I didn't make an example where I'd show you, this is the terrible amount of boilerplate we need, because I just didn't have time. All right, so going back to the IDE, right, font size and everything. Cool. So how does this stuff work? I'm gonna fly over this because I'm also feeling bored. I'm listening to myself. I'm like, this is long. So we're gonna stick to the application, the activity, and the activity view model, and the rest you'll have to take my word for it that it works. All right, so application. So if I jump into my application class, that's fairly simple how it works to inject it. Ignore that. All right, so when you have an app and you want to inject dependencies into it, so in this case, I actually have only the one right here, the activity lifecycle callbacks. For those of you who are aware what an activity lifecycle callback is, you're already getting a hint where I'm going with this. So that's the one dependency I want in my application, and I want Toothpick to give it to me. Cool. How do I inject the application that's going to get created? So I have to add code on my own in the onCreate of my app class. And alongside any other initialization code I might have, I'm going to go in here and start using Toothpick's KTX extension. So that's the KTP right here. That's like, that's what we're using. So first thing we do to initialize the whole DI tree and the whole scoping tree I just showed you is we say, okay, we're going to open a scope, and the key of this scope, the unique key in the system of this scope is going to be application scope class.java. So there's obviously only going to be one application, so that's cool. We don't need to worry about this. So that's our one scope, first scope in our tree. In there, there's going to be the record model I showed you earlier, that singleton. That's where it's going to live. So what do I do next? Well, So you saw earlier how I was injecting resources and shared preferences into my things. That doesn't actually come automatically necessarily. You have to explain to the DI system where it gets those. And there's this, it is though provided to you by the Toothpick. So Smoothie is part of the Toothpick libraries. So this is what we call a module. And a module effectively is where you define where Toothpick can find a copy of a thing. So thankfully what we can do here is just jump into it and sort of get an idea how that type of stuff works. So when you create the application module, Toothpick will create it for you. No, we just created it manually. Sorry, I'm not just saying anything. So the thing to note is that when the module is created, in a module there's a series of bindings. What's a binding? So you basically bind a class. So we're saying, if you want an application, you should use this. So as you can see, we're kind of cheating because if you note, the constructor we're calling, this is Java, if anybody forgot what Java looked like. So we're calling Smoothie application module with a copy of application, which we're then binding to the class application. So we're sort of cheating. We're passing our own dependency in, and then we're putting the binding in there, but it's a good example of how binding works. So anybody in the tree of scopes that wants a copy of application, right there and then, we just defined it at the top, so anybody underneath can ask for it, and it'll get it anytime. That's cool. And if you think about it, that's fine, right? You're not leaking anything. The context application is always okay. You can't leak anything if you hold on to it, so life is good. So then after that, there's all these other things, like account manager, ASAP manager, content resolver, handler, blah, blah, blah. So depending on how you should be getting these things, there's different types of ways of saying, okay, this is how we're going to get it. I'm not going to get into the whole DSL and library calls that you can do, but there's a few big concepts. You can either hook a class to an actual instance that's already been created. You can hook a class to a provider that which is effectively a factory that will build it for you or get it for you from somewhere. And you can also do things like letting Toothpick figure it out. So you can also do, if you don't need to, you can do just bind on a thing, and imagine that toInstance was removed here. Just like binding a class, you're telling Toothpick, hey, you're going to have to create copies of this thing, figure it out. So that's another way of doing things. And sometimes you have what are called implicit bindings, where you don't even need to do a binding at all. So what are those? I've already showed those to you. Whenever you have an @inject on a class, that right there lets Toothpick discover it automatically. And depending on the type of annotations you put on it, it will get scoped correctly. So if you don't provide any type of extra annotations, like I showed, the example I'm talking about is record model, it means that that will be bound to the application scope automatically. So that's nice for developers that don't like to mess around with module, which is most developers, because it allows you to quickly create bindings without having to look up that kind of stuff. Anyway, so the point here is a module defines how and where you will find things for Toothpick, and Toothpick, thankfully, will figure out whenever these things interdepend between each other, Toothpick will figure all of that out for you. But don't need to fear that code. It's just like a nice place to find examples. You never really, it's all done for you, right? All you need to do is install that one module. Cool. So, and then we use the scope we just opened, and we inject ourselves. So when you do that call, that's where this activity lifecycle's callback will be initialized and provided to the application instance that you have on hand. Now, before I go into very quickly what kind of stuff is happening in the lifecycle callback, and to give you an understanding of how these activities are getting automatically injected for you, I'm going to talk about a nice little new feature of Toothpick 3, which is the release calls. It's not something I've been using myself much, but something I often hear from folks who are really not familiar with DI frameworks is something like, what do you mean a singleton? Singletons are bad. Why did they put that in a library? That's stupid. Like I've had this argument so many times. So you might actually, who would be in that camp? So we can talk. Nobody, yeah. Good, I would shame you terribly. No, I wouldn't. The reason to understand why this is not a big deal, right, is that typically a DI system has scopes and you can actually close them. You can actually manage that. So it's not as if you were creating like the big old bad boogaboo of the Java world, like the top level singleton and a static somewhere, and just like leaving it hang on and letting the class loader decide whenever it's going to build it and all that evil stuff. Like, that's the old days. If you're using this, you're fully in control. When you open the scope, when you inject your things, that's when these things are created and you're controlling everything. But at the end of the day, some of your dependencies might be hash maps and caches and things like that, and those can leak, right? Those are kind of tricky. So what's nice now is that you can define releasable dependencies. So there's dependencies that Toothpick knows how to create, but if you call the release on the scope, it will take anything that's releasable and just dispose of it and garbage collect it. So what's nice there is if you have like a big hash map in one of those more temporary scopes I was showing you, you can tag them as releasable. And if we get a non-trim memory call from the system basically telling us, hey, there's memory pressure, we're going to kill you off soon, right, with a certain level, you get that call, you tell your DI, hey, flush, like, you know, just like flush everything down. There's a nice French expression for that, but I'm des écoutilles and something with boats, but I can't think of it for the life of me right now. Anyway, so that's kind of practical. Cool. I'm going to close on the activity lifecycle callback because I can sense the energy going down, and I'm also getting tired. So anyway, at the end of the day, you know this stuff exists and you know where to look for it, so all is good, and we can chat about it in a more lively way right after. So the activity lifecycle callback is something that you can hook up onto the Android system that will get callbacks anytime an activity is created, an activity is destroyed, or any other steps in the lifecycle, right? And you get the equivalent for fragments as well. So if you want to avoid someone having to type their own stuff on every class and potentially make mistakes every time they want to inject themselves, you do it for them here. You need to build a solid image of what you want to do and explain it well to people, but for all intents and purposes, once you've built this and hooked it up to an activity lifecycle and your system lifecycle, everything is basically for free. Like the injections are going to happen automatically. If the bindings are bad, it's going to break automatically, which is fine. That's what you want if people start defining and asking for things that make no sense. So I'm going to just very quickly skim over this code, explain the big ideas, not necessarily go too much into details. But again, we're using the KTP Kotlin-friendly extension functions right here. And what we do is we open the scope, application scope. So if you remember that graph, right, I'm just going to show it again a little bit, just so people have it in their mind's eye a tiny little bit. So we have application, we're at, and then what do we want under application? We want activity view models. So here, right there, I open an activity view model scope when an activity is created. And as part of that scope, I'm defining a few things here. So I'm doing all of this voodoo magic right here whenever a new activity is popping up. And I'm hooking onto the application scope, the activity view model scope. And I'm telling it, okay, if my activity implements this type of interface, which is view model binding, do this magical stuff that allows you to bind view models. We're not going to go into that right now. But more interestingly, whenever there's a view model scope being bound, Toothpick now allows you to say something like, please close that scope when the view model is cleared. So that's very nice because it will automatically close your scopes on your behalf when Google calls the view model to say, hey, we're done here. And then once you have this sort of lifecycle defined for Toothpick, you then can install modules that are specific to the scopes. I've showed you what a module is, and it defines bindings. So you can define bindings per scope, making sure that only people that are allowed to get access to certain things. So that means that if you want, for example, to avoid having activity view models get a reference to activity, because that's pretty much an automatic leak, then the scope I showed you earlier covers you, because activity itself is under a different scope. We never define how to find an activity at the activity view model scope. So if anybody that tries to create a view model that's hooked to an activity asks for this, Toothpick's going to break badly, which is what you want. And the same thing for fragments, anybody underneath. Right? So that's an interesting thing. Right, what else here? Well, that's kind of it. There's other things here that have to do with allowing users to define their own modules inline, but I'm not going to get into that. That's like pretty deep territory right there. And then there's this idea of opening the other subscopes. So I'm basically going through each call that open each of these successive scopes here on screen. So So now I'm looking at when we open the activity scope. This happens right there where the highlighted code is right here. So we take the activity, and that's going to be provided here and available at this level. And we install modules that are specific to the activity that will only stay and be, in the life cycle of the activity, will be collected every time an activity dies, yada, 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 you get the idea. And what's also interesting here is that we can automatically tell the scope and close yourself whenever an activity is destroyed. When your parent is destroyed, close yourself, clean yourself up, thank you. And then once all of that is set up, we can take the activity we have on hand, inject it, and then this activity, if it asks for view models, activity view models, it's going to get them. If it asks for dependencies that are in the activity scope that are shorter lived, it's going to get them as well. Everything is good, everything is fine, and it's automatically managed for you, and we are in really good shape. And that's basically what it is. Now, last call in this little block is this thing here. I'm not going to go into it because it's effectively doing the same thing for the subscopes, the fragments, and setting all that lifecycle up. And that's really deep weeds. Well, we're already there, but Cool. And then when the activity is destroyed, we just make sure that the scope is closed, which typically should never happen because we've just defined that it should close itself here. But sometimes I get paranoid. And as you can see from my note here, I'm just telling myself, we should check if this actually ever happens. And that's it. I'm going to stay at that, but no, we're done. We're good, we're done. So I'm going to put up the link to this, and I'm going to call it a day. Just get back to my slides. Do I have a thank you slide? I don't have a thank you slide. So thank you for listening to me. It's always a pleasure to share, and I hope we can share a lot. Okay, last thing, I promise, I'm just going to put up the GitHub repo if you're interested in this and want to take a look at it. It's called Record Store. See my mug up there, record store right there. So there it is. So if you want to look at the actual code and you're curious, look at the record store repo, and that's it. All right, thanks again. Take care. Anybody has extra word? Yeah, questions? Yeah, for sure. Go ahead. Yes, yes, absolutely, and it works pretty nicely. There's a very nice, so if you go see the Toothpick wiki, or even the Toothpick main page of the repo, there's like everything you ever want to know about testing has been done much better than I could have done it in the short time I had. So right here, if you want to take a picture, yeah, there we go. So. For reference, Toothpick is created by people who work and or used to work at Groupon, so this is coming straight from the source. So they explain how to do mocking. You get nice annotation that you can use in your test where by defining that something is a mock in the configuration of your test, when you inject it afterwards, Toothpick will automatically swap out things. So you can get a lot of control over your graph and how you can sort of mock the boundaries, but you could also let some things stay real. So if you have a fairly complex graph and I don't know, you have something that depends on a whole spider web of stuff, you could isolate that, just say I want this guy and those 3 other instances, but everything else should be a mock. And you can sort of define that these mocks will be built by Mockito, and then you can define rules around that. Like honestly, we have a few of those tests in production, and they're kind of hard to write. But I mean, it's really nice to have that flexibility, and there's like this article makes a good case of how to use it fairly simply, but you can push the envelope a lot there. So I feel like the Toothpick testing story is pretty good, but disclaimer, I've never actually really written tests with Dagger like in an extensive way, at least not Dagger 2. So, but yeah, if you want to take a snapshot of that one, it's a pretty good link, or just find it on the wiki. Any other questions? Okay, another round of applause.